So let's have a look at G. So we've got essentially y equals 2e to the cos 4x. Now, we said yesterday that if we let, if we've got y equals cos f, not cos, e to the f of x, the differential of that is f dash of x e to the f of x. Only thing here is I've got a constant, so now what I'm going to do is write f of x equals cos 4x. So f dash of x, we know how to differentiate cos 4x. When I differentiate 4x, I get 4. When I differentiate cos, I get minus sign. So this becomes minus 4 sine 4x. So now that I know what this is, I can then say dy by dx is going to be 2 times by minus 4 sine 4x e to the same thing as we started off with. And so we get minus 8 sine 4x e to the cos 4x. Okay, so that's where we stand with part G. Yeah, there we go. Right, so now I'm just looking at any sort of special questions. Right, okay, yeah. I want you to have a go at these questions. So the questions asked us to work out for part A, dy by dx. Dy by dx equals question mark. But in part A, what we are told, we've got x as the subject of this equation. So when we differentiate x, really we're going to get dx by dy, dx by dy equals 2y plus 1. How can I get dy by dx from here? Well, the chain rule. I said you can just multiply or divide anything to get essentially what you want. So here, dy by dx would be the same as saying 1 over dx by dy. Does that make sense? You let me know if you're happy with this version of the chain rule. There are many different things that we can do. So now, we've already worked out dx by dy. And so we can say 1 over 2y plus 1 is dy by dx. And that is the answer to part A. Are you happy with that? Okay, so this is now the second version of the chain rule that you are seeing. And ultimately, all the chain rule is saying is you can multiply or divide different things, and as long as you get dy by dx, that's fine. Okay. So this then becomes really easy once you get the hang of this. So the only other thing I wanted to mention here is to find the gradient at a particular point, to find gradient of tangent, because it now depends on y, we need y coordinates. We're not going to substitute x coordinates, we are going to substitute in y coordinates. Okay, because our answer is dependent on y. The gradient of the tangent is dependent on y. Okay, so that's the only thing I want you to be aware of for this question. So you want to make x a subject first. So my first step would be to say x equals ln y plus y cubed over 4. Or you could have said 1 over 4 ln y plus y cubed. Now, the benefit of writing it in the second way is that you can differentiate the bracket and just multiply, leave the constant factorized out. Okay, so now what I can say is dx by dy is a quarter. When I differentiate ln y, I get 1 over y. When I differentiate y cubed, I'm going to get 3y squared. But this is dx by dy. So then I will need to turn this into dy by dx. And the chain rule for that is 1 over dx by dy. And so I get 1 over a quarter 1 over y plus 3y squared. And so 1 divided by a quarter, I can take the 4 up there, say 1 over y plus 3y squared. And then if I did want to simplify it so that there's not a fraction, why does it become 1 over y? Because the differential of ln y is 1 over y. Or from yesterday, if y equals ln x, dy by dx was equal to 1 over x. So if I have x equals ln y, dx by dy is going to equal 1 over y. Are you happy with that? Okay, so we've dealt with that. Now, if I did want to simplify this further, I'd have to make a common denominator in the denominator. So let's do that. Because sometimes you will be asked to leave it in the simplest form, or you don't want to have a fraction within a fraction. So this is 1 over y plus 3y squared over 1. So if I cross multiply, I'm going to get 4 over 1 over y plus 3y cubed over y, which is the same as saying 4 over y plus 3y cubed over y, which is the same as saying 4 divided by y plus 3y cubed over y. And if I keep the first fraction the same, flip the second fraction upside down and multiply it, we end up getting 4y over y plus 3y cubed. That's your answer in its simplest form. Okay, are you happy with that? Any questions there? So I want an answer from all of you in here. All right, if I think about y equals e to the x, what is dy by dx? It was e to the x. So now all that's happened is I've changed the x's to y. All right, so now all this is going to happen is I'm going to get e to the y. Think about the relationship here. If y equals e to the x, dy by dx was e to the x. If x equals e to the y, dx by dy is e to the y. Okay, and then if you wanted to work out dy by dx, it's going to be 1 over e to the y. Okay, so I think a few of you had this confusion. Are you now happy with that? It's very important because I think a number of you have given me the wrong answer for this. Why doesn't it change? Just because, think about the relationship here. If y equals e to the x, dy by dx was e to the x. All that I've done is I'm just differentiating e to the y with respect to y. It's going to be the same. Okay. I'm literally doing an exact comparison of here to here. These two are equivalent, so therefore these two must be equivalent. What's the differential of y? The differential of y is 1, so it's 1 e to the y, which is e to the y. The differential of y is not y. Okay, does that make sense? Please let me know. I'm going to say y equals sine squared 3x. Now, what is the best way to write this in the first instance? Actually, the best way to write this in the first instance is going to be sine 3x squared. Okay, and this is what I meant when I said it all depends on how you write it. Okay, now if I think about this, this is a bracket to some power. So when I differentiate a bracket to the power, what happens? I bring the power down. I take 1 away from the power. I could write 1, or I don't need to write 1. And then I differentiate what's inside the square bracket. So when I differentiate what's inside the square bracket, we can use the general result for sine f of x, and we get 3 cos 3x. And so your answer becomes 2 sine 3x times by 3 cos 3x. And we can multiply the coefficients. This 3x is not going to change, but 2 times 3 is going to become 6. And so we get sine 3x cos 3x. Does that make sense? Okay, now I want you to talk to me about that. Right, where did the cos 3x come from? So I'm just going to do something quickly here just so you can see the parallel between it. If I had 3x cubed plus 7x to the power of 10, I would have said bring the power down, take 1 away from the power, times by the differential of what's inside the bracket. So I would have said 9x squared plus 7 here. Okay, and you're asking me where did this come from? It came from differentiating a square bracket. Okay, so it's exactly the same as what we are used to when we differentiate a bracket. Right, okay. So maybe not have too many ideas. Maybe try step 1. What's the first step that you're going to do here? The first step is to write it in sort of index form. So cos 4x to the power of 3. That's the first step. Now we know how to differentiate a bracket to any power. dy by dx, multiply the power down, take 1 away from the power of the bracket. This is the way I would do it, and then maybe if it can be simplified, I would simplify at the end, squared. Then I need to multiply by the differential of what's inside. Now cos f of x differentiated was minus f dash of x, so minus 4 sine 4x. Okay, so this is the unsimplified version. And it doesn't matter which order I write in. I could have written 3 times by minus 4 sine 4x. Cos 4x squared. Order of multiplication does not matter. Now the only thing that can be simplified, I can't multiply the 3 inside the squared bracket, but I can multiply the 3 in here. So we get minus 12 sine 4x, and then we get cos squared 4x. And actually we don't need this. We can have it there if we want, but we don't need it. Okay, does that make sense? So like we said, we're going to start off by writing it in index notation. That's got to be a starting point. So I'm just going to say y equals 3 plus cos 2x to the power of minus 1. Now, dy by dx, multiply the power down. So minus 1 is here. 3 plus cos 2x. Take 1 away from the power. Multiply by the differential of what's inside the bracket. When I differentiate 3, that's a number. Differentiate a constant, gradient 0. When I differentiate cos 2x, I am going to get minus 2 sine 2x. And this is a square bracket here. Does that make sense? Are you happy with everything I've done up to here? So now, if the power is minus 2, then that must mean that term is going to go to the bottom and it's going to be squared. So I'm left with minus 1 times by minus 2 sine 2x all over 3 plus cos 2x all squared. And so your final step is to say minus 1 times by minus 2 is 2 sine 2x over 3 plus cos 2x squared. Okay, so just one thing I spotted is this was not multiplied together, the minus 1 times by minus 2. Okay, so that's where I think one mistake was made. Other was when you differentiate 3, it disappears. Okay, and I can't see any other mistakes in here. Okay, any questions there? And this can be simplified. So y equals, I don't know, 3x to the power of 7. Differentiating this is quite easy. So I've got dy by dx equals 21x to the power of 6. But if I had y equals 2x plus 3 squared times by 5x minus 7 to the power of 5, that now has become a product which is going to become very difficult to simplify. I'll probably be sitting there for about 25 minutes if I was to do the binomial expansion and try to expand it, simplify each term. Yeah, probably about half an hour there, quite easily, trying to get a simplified version for y. And that's why there is a method in differentiation known as the product rule. And so what is the product rule? Product rule allows you to find the differential of a product, essentially, when two things are multiplied. Okay, so if we're of the form y equals u times by v, if we think about that, dy by dx is vu dash plus uv dash. And I'm going to explain this to you using the example that I just worked with. Okay, so here, let's have a look. So what I can see is it's a product of two separate things. I can call this whole thing here u, and I can call this whole thing here v. And I generally tend to write u and v on the side. So u equals 2x plus 3 squared, and v equals 5x minus 7 to the power of 5. Now, u dash is this essentially just differentiating whatever we have here. So can you please tell me what is the differential of 2x plus 3 squared as soon as you know what it is? And v dash as soon as you know what it is as well. This 2, I'm going to multiply the 2 down, take 1 away from the power, multiply by the differential of what's inside the bracket. So I get 4 times by 2x plus 3. And I'm going to leave it like that. Okay, so check your working out. I suspect some of you have forgotten to differentiate what's inside the bracket when you're using the chain rule. Okay, so just be careful with that. Now, similarly, when I do think about v dash, I'm going to multiply the power down. And then I need to multiply by 5 again, because the differential of what's inside the brackets is 5. So we end up getting 25 times by 5x minus 7 to the power of 4. Are you happy with that? Any questions there? Can you please look at your working out and tell me if you made any mistakes, what the mistake was? Now we're going to use the product rule. dy by dx is vu dash, so that means v times u dash plus u times v dash. So it's like cross multiplying really. V is 5x minus 7 to the power of 5. And I'm going to multiply that by u dash, which is 4 times by 2x plus 3, plus in the middle, u, which is 2x plus 3 squared, times by v dash, which is 25, 5x minus 7 to the power of 4. I'm going to put this dot to represent multiplication. Okay. Is everyone happy with this line of working out here? Anyone unsure about where I'm getting every single bit in here? Okay. So it's important that if you have any questions, you ask me. If you're unsure about anything, right? So now, the easiest thing to do is to take the number coefficient things to the front. So I can write this as 5x minus 7 to the power of 5, 2x plus 3, plus 25, 5x minus 7 to the power of 4, 2x plus 3 squared. Now generally, questions like this, they might ask you to put it in fully factorized form. Okay, so when I look at the fully factorized form, I have to pick out the highest common factor. And to do that, I go through a step-by-step process. First, I'll look at the numbers. Do 4 and 25 have anything in common? No, they don't. Then I will look at common brackets. Right, 5x minus 7 to the power of 5 and 5x minus 7 to the power of 4. What's the highest common factor there, please? What is the highest common factor out of the green underlined brackets? Right, that's good. So now that is common. And then if I think about this, the blue underlined brackets, what is the highest common power there, or the highest common factor, is 2x plus 3 to the power of 1. Right, so now I know what my highest common factor is. So 5x minus 7 to the power of 4, 2x plus 3 to the power of 1. And then what I tend to do is, as long as I've figured that out, I'll rewrite the line above. 5x minus 7 to the power of 5, 2x plus 3, plus 25, 5x minus 7 to the power of 4, 2x plus 3 squared, and divide each term by the highest common factor that I've just identified. So 5x minus 7 to the power of 4, 2x plus 3 to the power of 1. And same thing here, 5x minus 7 to the power of 4, 2x plus 3 to the power of 1. Well, this crosses out with this. And this is power 1, this is power 1. They completely cross out. So 5x minus 7 to the power of 4, 2x plus 3 to the power of 1. I'm left with 4 lots of 5x minus 7 for the first bracket, or the first term. This completely crosses out with this, and I'm left with 25, times by 2x plus 3. Are you happy with what I've done there? This is essentially factorizing. This is how factorizing works. So all I've done is factorize out 5x minus 4, 2x plus 3. And now what we're going to do is simplify the square bracket. I've got 5x minus 7 to the power of 4, 2x plus 3 to the power of 1. I don't need to write power 1. Square brackets, 4 times by 5x, 20x plus 50x. 20x plus 50x is 70x. Minus 28 plus 75. Minus 28 plus 75, I get 47, so that's good. And there's my fully factorized answer. This is dy by dx in fully factorized form. Are you happy with that? So I'm just going to write y equals x cubed 2x plus 6 all to the power of 4. So here I'm going to say u equals x cubed, v equals 2x plus 6 all to the power of 4. So u dash is going to become 3x squared, nice and simple. V dash is going to become 4, 2x plus 6 cubed times by 2. So we get 8, 2x plus 6 cubed. Okay, so that's where we stand at the moment. And so dy by dx is v times by u dash plus u times by v dash. And v is 2x plus 6 to the power of 4. I might need the whole page to do this. Times by 3x squared plus x cubed times by 8 lots of 2x plus 6 cubed. So if you get up to this stage, you know you're going to get most of the marks for the question. Okay, so as long as you got up to here, that's fine. Now here is where sort of writing it in a nice neat format helps massively. So 3x squared 2x plus 6 to the power of 4 plus 8x cubed 2x plus 6 to the power of 3. So go through this process, 3 and a, nothing common. Then x squared and x cubed. Right, okay, so I'm going to write x squared common, and then I'm looking at these brackets. So therefore I'm going to have 2x plus 6 to the power of 3 common. And then I'm going to rewrite the whole thing. You can, of course, do this bit in your mind. I just feel as if I'm going to avoid making mistakes if I do it like this. What have I got next? 8x cubed 2x plus 6 all cubed all over the highest common factor that we worked out earlier. So now x squared cancels out. This cancels out with this. So I've got x squared 2x plus 6 cubed, open square brackets, 3 lots of 2x plus 6. X squared crosses out with that. Cubed, they cross out. So I'm left with plus 8x. And so we are left with x squared 2x plus 6 cubed. And if I expand and simplify, 6x plus 8x is 14x. 3 times 6 is plus 18. Now, is that fully factorized? Is my question to you. Is that fully factorized? Looking at that, we can see that one of the brackets, this square bracket specifically, has 2 common inside it. So it's not fully factorized. So I can take 2 out of that bracket, write it at the front, 2x squared, 2x plus 6 cubed, and I've got 7x plus 9. And this is now fully factorized. So 2x plus 6, normally we would not be able to factorize it, but what we can do is factorize 2 out and write this as x plus 3 and write it like this. And so we have got 2 cubed and x plus 3 cubed, 7x plus 9. And so this is 8. 8 times 2 is 16. X squared, x plus 3 cubed, 7x plus 9. Okay, this required a bit more thinking. Okay, so one important thing actually, which is where most students would have gone wrong, and I didn't even sort of think to do that, which is very important, is to think about 2x plus 6. We know 2 is common in both of them, but instead of taking out 2, the common mistake would have been to say 2x plus 3 cubed. That is wrong. And that's why what we're doing is we're factorizing 2 out inside, oops, not 6. Factorizing 2 out of the whole thing inside square brackets, and then saying everything inside the square brackets is to the power of 3. Okay, and so we get 8x plus 3 cubed. And then if I do 8 times by 2, I get 16. Okay, so that was amazing, very good.